Hello and welcome back. Higher Maths, Functions and Graphs. We're looking at sets and functions, and in particular the domain and the range of a function. So we talked about what functions are, and we've seen them at National 5. So something of the form f of x equals x squared plus 1, for example. So we're going to look at restrictions on the domain. Remember, the domain is the set of all possible values that x can take. So two things we cannot do. We cannot divide by 0. So remember, when we're doing 10 divided by 2, for example, that means how many 2's make 10? So obviously 5 2's make 10. So what's 2 divided by 0? How many zeros do I need to make 2? Well, I've got 1 0, I've got 0. If I've got 10 zeros, I've got 0. If I've got 1,000,000 zeros, I still have zeros. So no matter how many zeros I have, I will never get 2. So we cannot divide by 0. So for example, this function here, f of x equals 3 divided by x minus 5. So here, the denominator, the term on the bottom, cannot equal 0. So this function cannot have 5 in its domain, because if x is 5, 5 minus 5 is 0, we end up trying to divide by 0. So what we would write the domain of f may be expressed formally as x is an element of R, which means x can be any number, then a colon, then x is not equal to 5. So it's literally anything except 5. And then remember curly brackets when using set notation. Also, we cannot square root a negative. We cannot square root a negative number. So we can't divide by 0, we can't square root a negative number. So here, the square root of 7x minus 2, what are the possible values for x? Well, this must be either 0 or greater than 0. We can square root of 0, the square root of 0 is 0. So whatever's underneath the square root sign, so 7x minus 2 must be greater than or equal to 0. So rearranging, add 2 to both sides, divide through by 7, x is greater than or equal to 2/7. So x is an element of R, but x is greater than or equal to 2/7. So let's have a look at a few more examples here. A function g is defined by g of x. Define a suitable domain for g. So what possible issues are there here? Well, we cannot divide by 0. We cannot divide by 0. So x plus 4 cannot be equal to 0. Subtract 4 from both sides. So x is not equal to negative 4. So that therefore the domain is x is an element of the real number. So any number except x cannot be equal to negative 4. 1b, here's a square root example. So function f is defined by f of x equals the square root of 5x plus 1. Define a suitable domain for f. So we cannot square root a negative. So 5x plus 1 must be greater than or equal to 0. So then subtracting 1 from both sides and then dividing through by 5. So x must be greater than or equal to negative 1/5. So there is our domain. X is an element of R, and x must be greater than or equal to negative 1/5. Remember, guys, curly brackets for set notation. And final example. H is defined by h of x equals root of 2x minus 1 plus 7 over x minus 1. Here we've got a combination of both. So we need to consider both here. So square root of 2x minus 1 must be greater than or equal to 0. So add 1 to both sides, divide through by 2. So x must be greater than or equal to 1/2. But also, we cannot divide by 0. So x minus 1 must also be not equal to 0. So x is not equal to 1. So we need to consider both of these when doing our final answer. So x is an element of R, x is greater than or equal to 1/2, and x is not equal to 1. Okay, so that covers both of them. That's covered the issue of square rooting a negative. It's also covered the issue of dividing by 0. So there's two things to do in that question.